The name of this project is Gas Pipeline Monitoring System for Hospitals. The pipeline distribution system is an integral part of all medical gas management systems. Without a properly designed, installed, and maintained distribution system, the security of the whole hospital can be at risk. Hence, with this project, we have implemented a system which monitors the storage of gas using pressure sensors and also the leakage of gas. So this project is done in three main phases. One is with the help of the walkway interface, that is the device simulation. And second one is connecting to the cloud using the IBM Watson IoT platform. And third one is creating a user interface with the help of Node-RED server that is run locally in your computer. So let us first discuss about the walkway interface. Walkway is an online interface which we use to simulate the IoT devices and also make connections between them. And we also code accordingly to the devices. So this interface is divided into two panes. The left pane, which is used for the code part, and the right pane, which is used for the device part. So first, let's discuss about the code part. To begin coding, we have to first include libraries that we use to use in this project. So first one, we have included a library for Wi-Fi, which is a Wi-Fi.h library. And second, we have included a library for MQTT protocol, which is a communication protocol. For that, we have used pubsub client.h. Apart from mentioning the libraries in the code, we will also have to add them manually in the library manager pane. So go to the library manager and then click on the plus symbol to search for the libraries and type out the library name. So you will have to select the name that appears in the drop-down menu and it will be added automatically. So here we also use the extra Arduino JSON library, which enables us to connect with the Node-RED interface. So let us go back to the code now. So moving ahead, we will define the pressure and leakage values by giving a variables to them. And then we will define a method called as callback in the future code lines. And then going down, we give out the credentials of the IBM account, the account in which we have created an IBM device. So for that, we will provide the IBM organization ID, the device type, device ID. Device ID is nothing but the number, and type is the name of the device, and then token, which is the authentication token, and data tree is nothing but the payload. So after defining the credentials of the IBM accounts, we provide the further information such as the IBM server and then publish topic format. Publish topic is the topic we send from the walkway interface to the cloud. So we send here we define the topic name and also the format of the topic, which is JSON. And subscribe topic is a command that we receive from the UI to the walkway interface. So here we use two potentiometers, one representing the pressure values and other representing the gas values. So connections are quite simple. You have to attach the ground of the potentiometer to the ground pin of the ESP32. And then you will have, this is for the recording of the potentiometer values. This we have to attach to the analog pins of the ESP32. And then this is the VCC is known to be the voltage input pin. We have to attach it to the voltage input pin of the ESP32, which is nothing but VIN or 3V3 pin. So after making the appropriate connections, click on the device simulation, which is the play button. We can see it is connected to Wi-Fi and the client is connected to the cloud server, and we can see the pressure and leakage values as well, and they have been sent to the cloud server in form of payload. You can change them manually by clicking on the dial on the potentiometer. So we have seen the change in values, and these same values are sent to the cloud platform. So now we are done with the walkway interface. Let's start it with your flow diagram. You will first be required to add nodes. For that, you have to select the drop-down menu on the top right corner and select the Manage Palette option. And then add the following nodes, which is the Node-RED And then IBM IoT app node, that is for the IBM IoT platform. Another one is the dashboard node, which provides you with the visual representation tools. And after that, click on close. You will find the node, all these nodes on the left side of the screen. So these are the dashboard nodes. So go to the IBM nodes and click on IBM IoT in node, since we are sending in the events from the Walkway device. Got the IBM IoT. So now connect this node to the debug node, which is generally the used for showing the debug messages. And then add, since we will be showing the pressure and gas leakage values and also the messages, alert messages to the staff, we will be making use of four functions, two functions, um, two functions belonging to the each statistic. So two functions for pressure and two functions for leakage. So for coming to the pressure, one function is pressure. So click on pressure. It simply shows the pressure values in form of a visual representation tool like a chart or a bar, graph, or etc. So you will have to define the payload as message.payload.pressure. We are attaching the pressure value to it, and then you are returning the message. So click on done. Then select the appropriate visual representative tool from the dashboards. Here we are selecting a line chart. So click on chart, and here we'll drag on it and add here. So double click on the chart to configure it. So group it accordingly under the particular tab. And then we have to label it as pressure since it shows the pressure statistics. And then you can type, we are selecting the line chart. You can select any of the chart according to your preferences. And then provide with the appropriate labels and ranges. Select the series colors and click on done. And then coming to the pressure status, here we show the alert messages. So double click on the function. So this is made up of a series of conditional loops. So if the pressure value uh, is less than 100, that means they have low pressure. And if it's greater than 2000, then high pressure alert is given. Or else the pressure is optimum. So you have to define like this and then click on done. So for showing the alert message, we generally make use of the text box. So to configure them, you have to again double click on the node. So select the value format, place them in the appropriate group, and also select the proper layout and click on done. So similarly, as we have done to the pressure values, do the same to leakage values. For leakage, we are selecting the gauge uh, tool. So let me once show the leakage function as well. So double click on leakage function. So here instead of pressure, we give out the leakage values that we have obtained from the water. And less than 2000, then the leakage detector is of medium amount, or else the leakage detector is of high amount. So then click on done. And here for showing the leakage alert status, we use the text box. So click on it, double click on the leakage status text and configure it accordingly, like placing it in a normal group and proper label, providing with the value format and layout as well. Then click on done. So with this, your flow diagram is complete. So in order to see the debug messages, go to the right top down menu and click on debug messages. As you can see, all debug messages are shown here. So in order to see the UI in different tab, go to dashboard in the same drop down menu. Then click on the icon that takes you to other tab.